Right, so let's continue in our series of these word problems. And this one is a slightly different word problem than the ones we have considered so far. So let's consider this carefully. Let's first read the problem and then we'll talk about how to solve it. So David and Mark are bricklayers. David can build a wall in 4 hours, while Mark can build a wall in 5 hours. If they both work together, how long will it take for them to build a wall? Okay, so David alone can build it in 4 hours, while if Mark is there to help him, it'll take maybe a little less than 4 hours, maybe it'll take 3 hours. So, but we have to find out how long will it exactly take, and that's what we are going to do here. So the way to approach these kinds of problems is to write it in terms of David and Mark's speed, basically. So let's give it a name. So speed of wall building, basically we have to consider that quantity, speed of wall building, which is basically number of walls built per hour, let's say. And let's denote SD is David's speed, which we know is 1/4 wall per hour, because it takes 4 hours for him to build a wall. And SM, which is Mark's speed, which is, because he takes 5 hours to build a wall, it is 1/5 wall per hour. So if he's given 5 hours, he can build 5/5 of the wall, which is the entire wall. Now these units are a little unnatural. This is 1/4 wall per hour or 1/5 wall per hour. This walls per hour is not a standard unit, but this is the natural unit for this problem, and therefore we are using it. And don't be afraid, you can use whatever unit you want. Ultimately, all that matters is conceptually what the unit means. So speed of wall building, which is a natural quantity to define in these kinds of issues or these kinds of problems, and the speed naturally happens to be in walls per hour. And it, even though nobody has used this unit before this video, it's fine, we can use this one. Maybe other people have also used this unit. I mean, it's a fairly standard way of operating. I'm not sure that anybody has named it as such, but maybe they have used it as such. So moving on. So this is David's speed and Mark's speed. We know how long it will take for each of them to build a wall, so we can calculate their wall building speed. So speed total, which is the speed that they will get when David and Mark are working together, will be David's speed plus Mark's speed, which is 1/4 plus 1/5 wall per hour, which is, if we equalize the denominator, this will be 9 plus 4 divided by 20. Not 9 plus 4, sorry, 5 plus 4. Which is, sorry, 9 divided by 20. I skipped a step, and it should have been 9 by 20. I wrote 9 plus 4. It's fine. So the total speed is 9/20th walls per hour. So now life is easy, because so time it will take, total time required, is equal to 1 wall. I'm purposefully carrying the units, you'll see why, divided by S total, the total speed at which the wall is being built. So this is 1 wall divided by 9/20th walls per hour. So I'm carrying the units because it's also a good sanity check for these types of problems, because we are working with non-standard units. It's not meters per second or kilometers per hour, it is walls per hour. So I don't want to make a mistake now that we have gone through all the steps here. So I want to see that the wall and wall units get cancelled here, and therefore I get 20 divided by 9. The hour in the denominator of the denominator will come in the numerator, so this will become 20 divided by 9 hours. Let's see if this thing makes sense. So this total time required is 20 divided by 9 hours, which is a little more than 2 hours clearly, because 18 divided by 9 would be 2. Does it make sense? So let's see, why should we expect this number to be bigger than 2? So David can build a wall in 4 hours and Mark can build it in 5 hours. Let's imagine Mark can also build it in 4 hours. Let's see what happens. Then David can build it in 4 hours and Mark can also build it in 4 hours. So if they are working together, clearly it will take them 2 hours total to build the wall, because let's say half of the wall is built by David, half of the wall is built by Mark, and they will each take 2 hours. So jointly again it will take 2 hours for them to build the wall. So clearly, because if Mark is going to take 5 hours to build the wall and not 4 as we did in the mental calculation, then it should take them a little more than 2 hours to calculate to build the wall. So it's one sanity check, this t, then this t is not less than 2 hours, or in other words t is greater than 2 hours is expected, and it's happening. So that's good. Another sanity check would be, so let's see. So David can build the wall in 4 hours. The faster of the two is going to take rather 4 hours to build the wall. So if Mark is just absent, Mark is just removed from the picture, then it will take David 4 hours to build the wall. So our final time that we have here is not going to be greater than 4 hours. So we expect t to be less than 4 hours, which it is. This 20 divided by 9 is clearly less than 4 hours. So that's another sanity check. So we have passed a couple of sanity checks. We have the correct units, and also we have gone through the math carefully. Basically we need to identify their individual speeds and add them in somewhat non-conventional unit of this walls per hour. But that's the way to approach these problems, that you have to set up the correct equation here, which is this is the defining equation of the problem. This S total is the sum of their speeds, which we can calculate, and then final time will be wall divided by total speed. So that's about it. So it will take 20 divided by 9 hours. I did not choose the numbers very carefully, otherwise I could have chosen integer numbers here instead of this 20 divided by 9. But that's not the point. The point is to get the concept clear. All right.